Thank you. Hello, everyone. This is Mohamed Ragab. I'm a PhD student, and I'm working under supervision of this handsome guy over here, Riccardo Tomazzini, and from University of Tartu. Today I will be talking about this bench ranking idea, the idea that we came up with while working with large RDF data processing and querying over the SparkSQL framework. And at the beginning, you might be familiar with this figure that depicts the linked open data cloud, and which represents also that we have large volumes of RDF data, and RDF data is now excluding. This is out of the popularity of knowledge bases and from the semantic web community. Although the fact that these RDF data is like graphs, but do you think that's graphs that you are querying? Actually, this is not necessarily true because although the fact that we have these native triple stores that you like natively can process and query RDF data sets using the full power expressiveness of SparkSQL, those solutions are mostly centralized, such as Gina and RDF triple X, JSTOR, etc. And those ones fall short when they have large volumes of RDF datasets or complex Spark queries, right? So that's why the semantic web community starts to find other solutions, such as like big data tools to process and query the RDF datasets non-natively in a relational realm. But we have like wide landscape of big data tools. And if we just pick one of these big data tools, like to relationally process and query large RDF data sets, it turns out that we have like some dimensions to consider, and the most non-trivial ones, like yet impactful 3 dimensions are the schema, partitioning, and the storage formats. And we have several options, right? We have several options under each dimension. Under schema, for example, we have this single statement table, we have vertical partition tables, also property tables schema. Partitions, we can partition the data, RDF data horizontally or using the subject or predicate keys, right? And also we have this like wide variety of row-oriented and columnar-oriented file formats, such as ORC and Parquet. So, like all in all, we have these like 3 dimensions, like we have 45 configuration combinations. And if we have picked one of these instances, for example, AI1 for the legend, this means that we have a particular schema ST and horizontally partitioned and stored using Abro, right? And since we are talking about graphs, if we represent these configuration combinations as graphs, we have these complex solution space, right? When we have a lot of attributes shared among these configuration combinations, right? For example, here CII1 at the left, top left, share this CII3, like because they share the same schema, right? So the question is, which configuration combination the practitioner should opt for or should select out of these complex solution space, experimental solution space, I mean. So it turns out that this problem itself is a big data problem. That's why we can apply some levels of like analytics, the 4 levels of analytics. And if we project this case to our case, we have this descriptive analysis in which we can describe which dimension was better and by how much. This is followed by the diagnostic analysis, try to describe why it happened using the domain knowledge, of course. For example, why VB is sometimes like usually better than ST because the number of joins in this schema is less than the number of joins in this schema. And third one, like it turns out that there is a still gap in big data communities, specifically in RDF context, in the predictive and prescriptive analysis. The predictive one, because we have a lot of dimensions, a lot of parameters to tune, right, in this context. And in this prescriptive analysis, what the practitioner should actually do, should actually select out of these dimensions, right? This also is a big problem, right? In our case, for example, this one that I mentioned. So this brings us to our ideas like bench ranking. As I have mentioned, looking at this descriptive level of analysis, like to the run times of the experiments, this is like overwhelming. And sometimes you have contradicting results, actually. And this is like because we have these trade-offs between these dimensions, right? And selecting the best configurations is not straightforward. It's not a trivial task to do. That's why we have like this idea of benchrank, which could be simple yet accurate way to find like the best configuration combinations. And the first proposal for a rank was proposed by Salim et al. And they tried to find like a rank for 7 approaches for partitioning RDF graphs, right? And their idea was like to rank these 7 partitioning techniques like through different number of challenges, right? The number of challenges were different number of data sets. We try in our work, we try to generalize this work by employing also the other 2 dimensions, which are the schema and the storage formats. So we have like now 3 ranking functions for the schema, partitioning, and the storage format, the 3 impactful dimensions that I have mentioned. So the goal is to have like recommendations or ranking set for every dimension of these ranking functions. But interestingly, when we run our experiments, we found that we have like for these 3 ranking functions, like ranking by format, by partitioning, by schema RS, we have totally different suggestions if we pick just the top 5 like suggestions or recommendations by these 3 functions, the ranking criteria. This doesn't mean these ranking dimensions are bad. Actually, each individual ranking criteria here try to optimize towards 1 dimension. For example, the ranking by schema try to optimize towards the schema dimension, ignoring the other 2 sides, which are the partitioning and the storage dimensions. The same for ranking format, the same for ranking by partition. And this brings us to the question of like how actually we can assess the ranking criteria goodness. Like, is there any metrics? In our work, we use these 2 metrics, the conformance metric and the coherence metrics. The conformance, like conformance with the actual query rankings, and the coherence, how coherent your ranking criteria while you scale, while you have like to scale up to larger data set. First one is the ranking goodness or ranking conformance. Like we state that ranking criterion is good if it doesn't suggest you some recommendations that actually performing bad. This is according to the actual query ranking, because for each configuration combinations over here, like we have ranks for the queries. We have, for example, AI1, this configuration combination like has a 35th rank for the query 1, etc. for the other queries. So this is our like ground truth. And if we picked one of these ranking criteria, ranking by format, we picked the top 5 configuration combinations, we have this like level of goodness or like conformance and the level of non-conformance shown over here by red and green. The second metric is the ranking coherence. Like as I have mentioned, coherence like here mean how the ranking criteria recommendations are coherent when you scale up to larger data set. And for that, we opted for Kendall index. Kendall index actually is like an index that counts the number of pairwise disagreements of 2 rankings data sets.
3 minutes.
Okay, so the larger the distance, the more dissimilar the rankings, and of course, the worse this ranking criteria. And to give you an intuition of this coherence, coherence, we have RF, RP, RS for the same data set, and we mentioned why they have like different recommendations, because they don't consider the trade-offs between the 3 dimensions. And when we have like the same ranking criteria over here, RF, for the same, but scaling up, we have seen some swaps, some disagreements between the ranking sets. And of course, the less swaps or disagreements, the better the ranking criteria to choose or to opt for. So experimental wise, we have like for this individual ranking criteria that I have mentioned, we have high coherence, okay. They give like coherent results, like reasonable coherent results when we scale up to larger data sets, but they give low conformance results or ratios. So that's why this brings us to the idea of like using bench ranking as a multi-objective optimization problem. We can look at as look at this problem as like a multi-objective optimization problem in which we try to maximize the three like dimensions all together, ranking by schema and ranking by partitioning and ranking also by file format. And this, we opted for that for the standard Pareto front algorithm in SGA2. And this algorithm tries to find the non-dominated solutions, like out of these configuration combinations, it tries to find you the like reasonable or like the most accurate ones for the three dimensions altogether, I mean. As a conclusion, I say that like we still have like a gap in the prescriptive analysis, and we studied this like while we working on the larger RDF graphs in the realm of relational world on top of Apache SparkSQL. We still believe, highly believe that Benchrank is simple yet accurate way that could help the practitioner or the decision maker to select the best configuration combinations out of complex solution space. And also, if you have trade-offs between the dimensions of this domain. And I conclude with this quote by George Box when he said, all models, actually all rankings are good, but some of them are useful. And thanks a lot. Yeah.
All models are wrong, right?
Are wrong, yeah.
They should be wrong. Thanks, Mohamed. So yes, we are at the end. Is there still somebody who has a question? We've got 17 participants still holding on there. Thank you for that. I also don't have a question at the moment. Somebody in the room here? No? Well, in that case, we have come to the close of this meeting. It's almost 8 p.m. in the evening in Copenhagen, but it's different times, different locations in the world. But we would like to thank you for this 4-hour event. Participating in it, actually there was a lot of participation, and that also made the program a bit cramped because there were also lots of people who wanted to talk, and but still I think it was interesting. So yeah, I presume there will be a 15th TUC meeting probably next year. Thank you for participating this time, and yeah, hope to see you then in another occasion. And of course, many thanks for Gabor Chanias, who put all this together in short time.
My pleasure. Thanks everyone for being on time with your talks.
Yes. Thank you for that.
See you.
Okay. See you. Yeah, we are closing the meeting. We will be posting. We will be trying to post the video on the LWC website, the link to the video on the LWC website.